Welcome back to ATech Hub. If you've ever looked at a massive web application and wondered, how on earth do they manage all that code without going crazy? Today's episode is exactly for you. We are diving deep into the absolute DNA of modern web development, React components. Think of a website like a car or a mobile phone. You don't build it as one solid block of metal. You assemble it from smaller, reusable parts like the engine, the tires, or the camera. In React, we do the exact same thing. We break our UI down into buttons, nav bars, and side panels, creating a tree of components that makes our code clean, modular, and infinitely easier to debug. In this episode, we're going to settle the debate between the old-school class components and the modern functional components that everyone loves today. We'll break down the magic of JSX, that strange mix of HTML and JavaScript, and we'll finally make sense of props versus state. Basically, how to pass data down like a baton and how to let your components remember things using hooks like useState. So whether you're just moving on from basic HTML or you're looking to sharpen your architecture skills, stick around. You're listening to ATech Hub. Let's get into the code.
That's a great analogy of the car, because it really gets to the heart of the philosophy. A React component is, at its core, just a small, reusable piece of the user interface.
Right, so you function.
Exactly like a JavaScript function. It takes in some inputs, we call them props, we'll get to that, and it returns a little chunk of HTML that tells the browser what to draw.
And when you say a little chunk, you mean everything,
Right.
From a giant sidebar to a tiny little icon inside a button?
Everything. The entire UI is just components. And that's the whole point. This shift from one massive page to, these tiny building blocks is why React became so dominant.
Oh, yeah. We've all seen that one file that's like 2,000 lines long and it tries to do everything.
And it's impossible to debug. A change over here breaks something completely unrelated over there. With components, you get this concept of modularity.
So you have your navbar.jsx, your footer.jsx, and a developer working on the navigation can't accidentally mess up the shopping cart logic.
Exactly. And that modularity gives you two huge wins. First is reusability. You build a really nice polished button component once.
And then you use it everywhere.
You use it everywhere. Consistent, tested, done. The second thing is team speed. Different developers or even different teams can work on their own components at the same time without stepping on each other's toes.
Okay, so you have this collection of component files, but they're not just sitting in a folder, right? They're connected.
They are. They form what we call the component tree. This is like the central idea of React architecture. You have a root component, usually called app.
And everything else lives inside that.
Right. App might contain a header and a body. The header has a logo and a navigation component inside it. It's a very clear hierarchy, and it controls how data flows through your application.
And while we're busy organizing our code like this, React is handling a really complex problem for us under the hood, isn't it? The actual updating of the screen.
Oh, absolutely. That's its main job. In the old days, developers had to manually change the browser's DOM, the document object model.
Which is super slow and inefficient.
Incredibly slow. So React uses a virtual DOM. It's basically a lightweight copy of the real DOM that lives in memory. When something changes, React updates this virtual copy first.
It doesn't touch the real browser display yet.
Not yet. First, it runs a diffing process. It compares the new virtual DOM tree to the old one, finds the exact spot that changed.
Like just the text inside one button?
Precisely. And then it makes only that one tiny specific update to the real DOM. That efficiency is why React feels so fast and responsive.
Okay, so let's unpack the language we use to actually write these components. I'm talking about JSX. It looks kind of weird to newcomers.
It does. It looks like someone dropped HTML into the middle of a JavaScript file, because that's sort of what it is. JSX stands for JavaScript XML.
It lets you write that familiar HTML-like structure right inside your logic.
Exactly. You get the power of JavaScript for your logic, but the declarative, easy-to-read structure of HTML for your UI.
But wait, browsers don't understand JSX, right? They only speak JavaScript.
That's the key. It's syntactic sugar. Before your code ever hits the browser, a tool like Babel compiles it. So that H1 hello 1 you wrote, it gets turned into a plain old JavaScript function call. React.createElement, H1 null hello. The browser only ever sees the JavaScript.
Got it. And that translation process explains some of the strict rules, like the naming convention.
Pascal casing, it's non-negotiable. Your components have to start with a capital letter, like user profile.
Because React needs to tell the difference between our custom user profile component and a standard lowercase HTML tag like div.
If you write user profile with a lowercase u, React will think you're trying to render an HTML tag that doesn't exist, and it'll just fail.
The other rule that always gets people is the single element rule. You have to return one and only one parent element.
Right. If you want a heading and a paragraph next to each other, you have to wrap them in something, usually a div.
Or the cleaner way now is the fragment.
Yes, empty brackets, no. It satisfies React's rule without adding an extra useless div to your final HTML. It keeps your DOM clean.
So we have the structure. How do we make it dynamic? How do we get, variables and data in there?
That's what the curly braces are for. They're your escape hatch back into JavaScript land. Anytime you're inside JSX and you need to use a variable or call a function, you just wrap it in curly braces.
You see this all the time for showing or hiding things. Conditional rendering.
Yeah, and the most common pattern there is the logical AND operator. And
Loaded user profile.
Exactly. If iLoaded is true, the component renders. If it's false, the whole expression is false, and React renders nothing. It's super concise.
Okay, this brings us to the big one, the real evolution of React. We have to talk about class components versus functional components.
The great debate. So historically, functional components were very simple. They were called stateless components. All they could do was take in data and return some JSX. No memory, no logic.
They were just for display.
Pretty much. All the heavy lifting, all the state and logic had to be done in the class component. This was a big ES6 class that extended React.component. It was the only way to make a component that could, remember things or react to events.
So if classes were the only way to get real functionality, what changed? Why does everyone now say to use functional components for everything?
One thing, React hooks.
Hooks?
When hooks were introduced, it was a seismic shift. Suddenly, these simple, clean, functional components could do everything class components could. They could have state, they could have lifecycle effects, everything.
So what's the real advantage then? Why ditch the class?
Honestly, it's this keyword.
Ah, yes. The bane of every JavaScript developer's existence.
You mean in class components, you were constantly having to bind this to your methods. It was confusing, easy to get wrong, and a huge source of bugs. Functional components just don't have that problem. They're just functions. They're simpler, more predictable, and way easier to test.
So for any new project today, the answer is just use functional components.
100%. You still need to understand class components to work on older code bases, but for anything new, it's functions all the way.
All right, let's switch gears from the architecture to the data itself. Props versus state. This is how components actually talk to each other and remember things. Let's start with props.
Okay. So props, which is short for properties, are the inputs. They're how a parent component passes data down to a child component.
Like function arguments.
Exactly like function arguments. The parent might have a user's name, and it passes that name down to a greeting component as a prop.
And there's one golden rule about props, right?
They are immutable, read-only. The child component that receives the prop should never, ever try to change it.
Why is that so important?
It creates a predictable, one-way data flow. Data always flows down the tree. If any child could just randomly change the data it received, you'd have chaos. You would never be able to track down where a bug was coming from.
So props are the unchangeable data coming in from above. What then is state?
State is the component's private internal memory. It's data that the component owns and can change over time.
Like the text someone is typing into a search bar.
Perfect example.
Oh.
Or whether a drop-down menu is open or closed. That's state. It's mutable, it can change, but it is totally private and isolated to that one component instance.
And in modern React, with our functional components, we manage that memory with the useState hook. How does that work?
So when you call useState, you give it an initial value. What it gives you back is an array with two things in it.
Right. You get the value itself and then a function to update it.
Exactly. You'll almost always see it destructured, like const count, set count, useState 0. Count is your current value, and set count is the only way you're allowed to change it.
This is the part that trips up every single beginner. Why can't I just say count plus 1? It's a variable.
Because React needs to know when you change something so it can re-render the UI. If you just change the variable directly, you've updated the value in memory, but React has no idea. The screen won't change.
So calling that setter function, setCount, is like sending a signal to React.
It's placing an order. You're saying, hey, React, my state has changed. Please schedule an update to the screen. That function call is what triggers the whole virtual DOM diffing process we talked about earlier. It's the core of React's reactivity.
Okay, so this is all starting to click. We pass data down with immutable props. Components remember their own private data with mutable state. But how do we close the loop? What if a child needs to tell a parent that something happened?
That's a classic problem. It's often called lifting state up. And the solution is actually really elegant.
You can't just send data up the tree directly.
No, because data only flows down. So instead, the parent passes a function down to the child as a prop.
A function is a prop.
Yes. So the parent defines a function, like handle item click. It passes that function down to a button component in a prop called, say, onClick. When the user clicks the button, the child component doesn't know what to do. It just knows to call the function it was given.
And when it calls that function, it can even pass data back up with it, like the ID of the item that was clicked.
Precisely. The function executes back up in the parent scope, the parent updates its own state, and then re-renders everything that needs to change. It completes the entire data flow cycle, but keeps it clean and one-directional.
Wow. That pattern really is the key to building complex applications that are still easy to reason about. Okay, what a session. We've covered so much. We started with the component tree, this idea of modular reusable code.
And how the virtual DOM uses that tree to make performance lightning fast. Then we dove into JSX, that mix of JavaScript and HTML, and its rules like Pascal casing.
We settled the big debate functional components won thanks to hooks like useState. And we finally clarified the difference between immutable props for passing data down and mutable state for a component's internal memory.
And we established that you only update state with the setter function to make sure the UI actually updates.
Right. So if we bring this all back to that virtual DOM idea, we said React is smart about only updating what's necessary. But that implies it's doing a very fast comparison.
It is. And that leads to a really interesting follow-up question. What specific algorithm does the virtual DOM use to compare the old tree and the new tree so quickly? That process is called reconciliation.
So it's not just a blind comparison.
No, it has rules and heuristics to make it efficient. And understanding that diffing algorithm, especially how it uses special things called keys to identify elements, is probably the next big step for anyone wanting to optimize their React app's performance. It's a great area for you to explore next.
If you enjoyed this deep dive, please remember to share this knowledge, like this tech dive, and subscribe to the channel for more technical shortcuts.